So now we will see the how we try to delete an element from the beginning of a single linked list. Deleting an element at the beginning, how to do that? Okay, you have a list already with you here, 4, 15, I have elements 4, then 15, then 7 and 40. I want to delete this first node itself. And we always know there is a pointer by name head. This head is always pointing to the first node. So I got the node, I got the location directly. Okay, I got the location directly. I want to delete this element 4. For that, this will become my head, right? After that, this will become my head. So I have to shift my head from this location to second location. How do I do that when I want to shift it? So create a temporary variable, let this be temp, let this be temp. Now what is temp's next? Temp is this location, its next will be this location. Temp's next will be this location. So my temp next is currently pointing to location 15, the element 15. Okay, this I have to make my head. This I have to make my head. That's it. When you make this as head, this is gone now. This entirely gone. This list is, this element is gone, because we always know that the linked list, the first node, the beginning node is always pointed by head. Head pointer is always pointing to the beginning of the list. So logic is very simple. To delete an element at the beginning, take a temporary pointer pointing to head. Then what is temp's next? Temp's next is this. Temp's next is this box. This one you make it head. So this becomes your head now. This becomes your head now. Okay. When this becomes head, where is your temporary pointing? Temporary is pointing still to this. Just use the command free of temp. Free of temp means it will delete this memory location. So only this becomes your list. Okay, logic is very simple. If you want to delete an element from the beginning of the list, what you have to do here? You have to take a temporary variable pointing to head. Temp's next will point to this location. That temp's next, you should make it as head. You should make it as head. Then you delete this temp. You delete this temp. Or else you may say, sir, why I have to use temp? You need this temp to delete it actually. To delete this node, you need temp. So for that, what we are trying to do here, you can write like this, head equal to head next. This is also fine. Where is head? Here. What is head's next? This one. This you make it head. And simply write free of temp. When you do this, this is your temp, right? That will be erased. If you remember the function free, right? Like malloc, calloc and realloc, we have one function free to delete the dynamically allocated memory. So that will delete this particular box. That is as simple as this. Let us see the implementation of this deleting an element at the beginning of the list. If you see here, again delete at the beginning of the list, I am passing head because head is the only reference I have. I am creating a temporary variable and you check if head is null. It means there is no list at all. List does not exist. In that case, you say list is empty. In that case, you say list is empty. Otherwise temp equal to head, right? This one, temp equal to head, map temporary to head, then head equal to head next. So head's next, this location becomes your new head. Head equal to head next. Free temp means it will erase, it will delete this memory location. Okay, very simple code to understand how to delete an element at the beginning of the list. Okay, so you are creating a temporary variable and you are making the temporary as head. It means both should point to same location. Then head equal to head next. You are moving your head to, you are making this as your head. You are making this element as your head. After that simply free of temp means this will be deleted entirely. So your list becomes now very simple. Your list becomes like this: 15, 7 and 40, that's it, and this becomes your head. So this is the logic of deleting an element at the beginning. It is very simple. Let's go for the next important operation in single linked list, that is deleting an element at the end. So when you have a list, when you have a linked list with you, you want to delete an element like this. I have a list like this: 5, 1, 17, 4. I want to delete this element. I want to delete this last element. To delete this last element, we always know that what you have to do, you have to traverse the list. You have to traverse the list. How long should I travel now? Where should I go and stop? Should I reach here? Should I reach here and delete this? Okay, simply what can be done is, you can take a temporary pointer t. Okay, take a temporary pointer t and take another temporary pointer. Maybe you can take two pointers here, p and q. P and q. Now bring your p to this location. Bring your p to this location. How? By traversing. If p of next is not equal to null, with this command you iterate and reach here. Okay, next you bring your q here. You bring your q here. That's it. What you have to do? Q's next. Just simply make it null. When you make this as null, this chain is broken. This chain is broken. And why we need this pointer p here? Because we have to free it, right? We have to delete that memory. For that I have taken p, free of p. Okay, so what is the logic of deleting an element at the end? Deleting an element at the end is, your head is here, take two pointers p and q, let p reach here, let q reach here. Okay, let p reach here, let q reach here. Then you just make q's next element as null. Make q's next element as null. Just make this as null. That's it. This chain is broken here. Then at the end you write free of p. This will be deleted from the memory, because memory we have to delete, right? Once you are creating a new block, what you are doing to create a new block? See, you are writing this statement, right? New node equal to malloc. You are allocating memory. You are creating a new memory location using malloc function. So that's why using free function you have to delete this block, so that the element is deleted. Element is deleted. Is it clear? I hope you understood how to delete an element at the end. Okay, we will see the logic, how I can make this p and make this q and p. How do I get this? We will see the logic. It's as simple as that. You always go, if p's next is not equal to null. Okay, if or while whatever you say, and if this is not null, then you write your q equal to p and then write p equal to p of next. So initially here I will have p, here I will have q. Now this is while. Okay, this is our while, right? Now see here, while p is next not equal to null. P is next, is it not equal to null? No. Then write q equal to p. So my q and p point to same location, p equal to p next. So because of this, what will happen? This will become my p. Again go back to the while loop. While p is next not equal to null. Is this p is next, is it not equal to, is it equal to null? No. In that case you are writing q equal to p. So you move your q from here to make this as q, and you are writing p equal to p next. After that you are moving here p equal to, so your p points here now. Again go up and check whether p is next is not equal to null. Is this equal to null? No. Then q is equal to p. So make this as your q, make this as your q, erase this, and p equal to p next. So I am moving my p from here to here. Now again go back to the list, while condition. While p is next not equal to null, but here I have null. I have null, this condition has failed now, it will come out. So after writing these 3 statements, where is your P? Your P is here. Where is your Q? Your Q is here. That's what we wanted. We want our Q to be here, we want our P to be here. What you have to write? Once you write this while loop, what you have to do? Just Q's next, make it null. Make this as null. One step is over. Then you write free of P. Delete this from the memory. So this is the logic of deleting an element at the end. Okay, let's see the code logic for this to understand how this works. So what I said here, again create a function delete at end, and head is our input always. So I am creating, see, 2 pointers P and Q. I am creating 2 pointers P and Q. See the logic. This is a basic check again to check if head itself is null. To check if head itself is null, then we will delete that node. Okay, we will delete that head itself. For that, this one basic check. Otherwise you see P equal to head. Okay, so this is the list. If this is the list, 10, 20, 30, and it is pointing like this, and there is null. So this is my head. I am making this as my P. Next, while P next not equal to null. Okay, while P next, where is P? Here. What is its next? This one. Is it null? No. Then Q equal to P. Then Q equal to P. So make this as your Q. Then P equal to P next. So P will point here now. P will point here now. Okay, so P is here, Q is here. Again go back and iterate. Is P's next not equal to null? Is this null? No. Then make this as your Q, and you shift your P from here to this location. So your Q has been updated. Your Q has been updated to this location, and P has become this. Again go up and check the while condition. Is P's next not equal to null? No, it is null. Stop the process here. So your Q is here, your P is here. What you have to do? Q next equal to null. So just break this relationship and make this as null. Then free P. Free P means this will be deleted from the RAM. The memory allocation will be deleted. So your list becomes only 10, 20. Okay, so logic is as simple as this. I hope you understood how we are trying to delete an element at the end of the list. I will repeat the logic here. What you have to do? Take 2 pointers P and Q. So let P point here. If this is null, if this is not null, move your P to this location and update this as Q. Then if this is null, then move your P here and move your Q to this location. Then if this is null, no. Then move your P to this location and make this your Q. Is this null? Yes, stop. So we got our Q here, we got our P here. Just make Q's next as null and delete this P. How to delete this P? By using function free. That's it. So this memory location will be deleted and our list will become only 4, 15 and 7. Okay. So this is the logic to delete an element at the end. Now the last and important concept, that is deleting an element at any given position. Okay. Right. Why we have to deal with data? Why we have to deal with the data? I am least bothered about the data. I want to delete this node, whatever data it may contain. I want to delete this node, whatever data it may contain. That's why we are not worrying about the data inside the value, inside that node. I am not considering that. I want to focus only on to reach this location. I want this node's address, this node's address. This node's next pointer you make it null and delete this. Whatever element it may have. That's why by default blindly delete the element at the end. The third one and the very important one, deleting an element at some given position. How to delete an element at some given position? So what is the logic here? Let us take and understand an example. See, you have a list 4, 15, 7 and 40. I want to delete an element at position 3. At position 3 I want. So this is position 1, position 2, 3 and 4. I want to delete this element at position 3. So, what is the logic here? See, when you have a list like this 4, 15, 7 and 40, when you have a list like this, you want to delete this element. Okay, you want to delete this element, you want to delete. When you want to delete this element, only operation what you have to do is, you should know this address. You should know this address. Let this be Q, let this be P. Same logic. Reach to that position, let this be Q, let this be P. Simply Q's next point to P's next. Okay, Q's next point it to, what is P, where is P here, what is its next, this one, that you point it. Okay, so traverse the list, find out your Q, find out your P, that is first step. Then Q's next point it to this P's next, that is this block. Q's next is 15, P's next is 40. Link this 15 to 40, that is it, and then you free this P, that is the logic. So, what we are trying to do, see the node to be deleted, this is my P, previous node, this is my Q. What you have to do, this Q's next should point to P's next, and then you delete this P using the command free of P. Okay. So, this is how we try to do this. Be very careful, the logic is simple. You have your head pointer, let the P be here, okay, let the P node be here, traverse the P node to the location where you want to delete, to the position which you want to delete. So, by that logic, while loop logic, we will see that logic, you make this as your Q, you make this as your P. After this, Q's next part, this location should be pointing to this location. How do I get this? Using P I can get it, because this is P's next, P next is 40. So, Q next I should make it as 40, that is it. This chain is broken, this new chain is formed, then you free this P, you write free of P, this node will be deleted. Okay. Let us see the code of how do we do that. I think you remember that we need always a position. Why we need position? Because the topic itself is deleting an element at some position, So, that should be given as an input for us. So, as usual, head is given and position is given, head and position are given. See, I am taking two nodes P and Q, I am taking two nodes P and Q. What I am doing here, P equal to head. So, I am making in the list, if I draw a small list here, so this contains 10, 20, 30 and 40, this is null, this way they are linked. So, this is position 1, position 2, position 3, position 4, okay, and this is my head, this is the list. I want to delete at any given position, let the position be 3. Let the position be 3. So, see what I am doing. First step is P equal to head. I am making this as my P, fine. I equal to 0, okay, 0 less than position, okay, 0 is less than 3, true, 0 is less than 3, true. Q equal to P, I am making this as my Q. Then P equal to P next. P from here, I am making this as my P now. I am making this as my P now. So, Q is here, P is here. Again go back, I plus plus, I becomes 1, 1 less than 3, 1 less than 3, yes, true. Q equal to P. Make this as your Q. Make this as your Q. So, this will be deleted. This Q is gone from here. And what I am doing next? I am writing P equal to P next. So, this becomes my P. This becomes my P. Again go up, do I plus plus, I becomes 2. 2 is less than 3, okay, small mistake here, it should be position minus 1, this should have been position minus 1. So, 2 is less than 3, right, when 2 is less than 3, it will, next iteration it will become 0 is less than, when position is 3, when position is 3, it becomes only 2. So, 0 less than 2 and 1 less than 2. So, we reached here, this become our logic. Second time when I go and increment, it becomes 2. 2 less than 2 is false. So, I have reached the third position. My P is pointing to third position and my Q is pointing to second position. Now what I have to do? Q's next. Q's next is this box. This should point to P's next. Where is P's next pointing to? This box it is pointing to. So this link I am trying to create. Then I am doing free of P. Delete this node. That's it. It is as simple as that. Okay. I will repeat once again. Deleting a linked list at any given position. So what we are trying to do, when you have a list like this, right, this is position -1, the correction here. So these are linked like this, and this is your head pointer. Create this as P. Check if this is, and the position is given as 3. Then you have to go till 2. You have to go till 2 only. That's why position -1, because I am beginning my I from 0, no? That's why position -1. If you make this I as 1, then not a problem. Okay. So P is here. Check if this is the position. No. Then make this as your P. Make this as your Q. Again check, is this the position? No. Make this as your P and make this as your Q. Yes, we reach the position. Simply this Q's next you point it to this one and free this. So this is the logic of deleting an element from the list. Okay. If you summarize what we have seen, to delete an element at the beginning, what we are trying to do, we are trying to take a temporary pointer and we are making this as our head. We are trying to make this as our head and delete this. This is inserting at beginning. Inserting an end, what you have to do? You have to find out your Q node, you have to find out your P node. Q and P node I am trying to find out. How am I finding this? By traversing the entire list. Once I reach this here, just make this as null and delete this. That way we can try to delete at the end. At any given position, what you have to do, whichever is the position, that you make it your P, reach there, and its before location make it as Q, and its before location make it as Q. Simply this Q's next you point to P's next. Okay. So this is the logic for implementing the deletion at position, at the given position. This is the logic. Okay. So I hope it is clear, these 3 different operations on single linked list. So we will see the implementation part of this using C++.